Let's begin talking about the AWS Cloud Practitioner certification. The certification path is envisioned for candidates who desire to gain and then demonstrate a general understanding of the AWS cloud. This path is beneficial for people in technical, management, compliance, security, sales, or financial roles who are operating in the Amazon Web Services cloud. The exam, CLF C01, qualifies individuals with a broad and overall knowledge of the AWS cloud to validate their understanding with an industry-recognized credential. Platform knowledge will include available services and their common use cases, architectural principles at the conceptual level, account security, and compliance. The Cloud Practitioner candidate must also show an understanding of AWS cloud economics, such as costs, billing, and analysis, and the value proposition of the AWS cloud. The exam also validates several other abilities. For instance, costs, economics, and billing practices, core AWS services, services for common use cases, value of the AWS cloud, the AWS shared responsibility model, and cloud security best practices. According to Amazon, it's recommended that candidates have at least 6 months of experience with the AWS cloud. However, that's not a prerequisite, and it's not necessary to take or even pass the exam. However, candidates should have a general knowledge, a basic understanding of IT services and their uses in the AWS cloud platform. There are 2 types of exam questions: multiple choice single response, where you have 1 correct response and 3 incorrect responses or distractors. The other type is multiple choice multiple response, where you have 2 or more correct responses out of 5 or more options. These will be your more difficult questions. However, none of the questions will ask you to do any configuration. Other exam characteristics include the fact that this is a pass-fail exam. You must have a score of 700 to pass the exam on a scale of 100 to 1000. At the end of the exam, you'll get a score report showing a table of performance classifications at each section level. This table will contain general information, highlighting your strengths and weaknesses. Each section of the examination has a specific weighting, so some sections have more questions than others. And the exam uses a compensatory scoring model. In other words, you don't have to pass all the domains. Here are the 4 domains. Domain 1, Cloud Concepts, 26%. Security and Compliance, Domain 2, 25%. Domain 3 is Technology, 33%. And Domain 4 is Billing and Pricing, 16%. Here's a breakdown of the domain concepts. 1.1, define the AWS cloud and its value proposition. 1.2, identify aspects of the AWS cloud economics. 1.3, list the different cloud architecture design principles. 2.1, define the AWS shared responsibility model. 2.2, define AWS cloud security and compliance concepts. 2.3, identify AWS access management capabilities. And 2.4, identify resources for security support. 3.1, define methods of deploying and operating in the AWS cloud. 3.2, define the AWS global infrastructure. 3.3, identify the core AWS services. And 3.4, identify resources for technology support. 4.1, compare and contrast the various pricing models for AWS. 4.2, recognize the various account structures in relation to AWS billing and pricing. And 4.3, identify resources available for billing support. That's the AWS certification and exam. In the next lesson, we'll define cloud computing. In this short lesson, we're going to define cloud computing. Now remember, the word cloud simply means a large accumulation of something. For example, water particles in the air gives us a visible cloud. Now, according to Amazon Web Services, AWS, cloud computing is the on-demand delivery of compute power, database, storage, applications, and other IT resources through a cloud services platform via the internet with pay-as-you-go pricing. Cloud computing provides a simple way to access servers, storage, databases, and a broad set of application services over the internet. A cloud services platform owns and maintains the network-connected hardware required for these application services while you provision and use what you need via a web application. With cloud computing, there is no need for the customer to make large upfront investments. The customer no longer needs to spend time managing hardware and cabling. If you've ever worked in a server farm or a server room or a data center, you know exactly what we're talking about. Racks and racks of equipment, yards and yards of cabling, distribution frames, and the like. And you can provision the exact computing resources necessary, as well as, and just as importantly, deprovision when needed. Cloud computing supports a wide variety of emerging technology. Blockchain technology, for example, for developing cybercurrency or other immutable solutions. Virtual reality and augmented reality, for example, developing the next Pokemon Go. Internet of Things, IoT, and other microservices, machine learning, and artificial intelligence tools for a wide variety of analytic purposes. Robotics solutions, and emerging database technologies like graph databases, blockchain databases, and time-based databases. Now that you have a fundamental definition of cloud computing, in the next lesson, let's learn about the three main types of cloud computing services. In this lesson, we're going to look at cloud computing service types, and there are three main types of cloud computing, and each one signifies a different aspect of the cloud computing stack. We have Infrastructure as a Service, or IaaS, Platform as a Service, PaaS, and Software as a Service, SaaS. And it's common for a customer or a consumer to use two or more of these cloud computing service types. And some managed services can actually be a combination of, let's say, Software as a Service and Platform as a Service. But let's define these one at a time. Infrastructure as a Service is often called IaaS, or as an abbreviation, IaaS. It provides the basic components for cloud information technology, usually offering access to the networking infrastructure of the provider, virtual or dedicated server computing, and that could be Linux and Windows servers and other applications running on those servers, as well as serverless computing. For example, functions as a service or containers running serverless in the cloud, as well as data storage space. IaaS is the most comparable to existing IT resources that many IT enterprises and developers are familiar with. It delivers the maximum amount of elasticity and flexibility and administrative control over the consumer's IT resources. A prime example of Infrastructure as a Service at Amazon Web Services is their virtual networks, or virtual private clouds, known as VPCs. Every account has one default VPC. The VPC allows you to provision a logically isolated portion of the AWS cloud. You have complete control over your environment. The gateways, the various firewalls, placement of endpoints to a wide variety of services, peering VPCs to each other, and more. You can choose your own IP version 4 or IP version 6 address ranges and subnet design. You decide if the subnet is public or private or a VPN subnet. You configure route tables and network gateways. All of these elements are horizontally scalable and run in the provider's cloud infrastructure. Our next service type is Platform as a Service, or PaaS. Platform as a Service eliminates the need for enterprises to manage an underlying development infrastructure. It lets the customer focus on the rapid and agile deployment of applications, containers, mobile apps, microservices, and more. Platform as a Service enables the DevOps team to be more efficient, more iterative, more agile, continually integrating, continually deploying. It removes the concerns over resource acquisition, capacity planning, software maintenance, and patch management. Platform as a Service eliminates any of the other undifferentiated heavy lifting involved in running your app or application. Customers still do not manage or control the underlying AWS infrastructure. With Platform as a Service, consumers may control applications and services. Programming languages, libraries, services, and a wide variety of tools are provided by the service provider, in this case, Amazon Web Services. And some services are more managed by AWS than others. So when you're choosing the Platform as a Service type, there's a more gray area between the demarcation point between you, the customer, and AWS, the provider. It can depend upon the service. For example, you could use the Managed Relational Database Service from AWS, or you could use the fully managed AWS Aurora service for MySQL and PostgreSQL. Platform as a Service uses a wide variety of different languages like Java, Python, Ruby, .NET, JSON or YAML, and relational database services, supporting at least 5 different platforms, like Microsoft SQL, MySQL, and PostgreSQL, to name a few. A good basic example of Platform as a Service is using Amazon Lightsail. For the small to medium-sized business, Lightsail offers everything you need to build an application or website using a cost-effective monthly solution. It provides virtual servers, storage, databases, and networking. It's excellent for simple web applications and websites, business software, and development or testing. And recently, Amazon Web Services added content delivery networking services to Amazon Lightsail, so you can get your content as close to the consumer as possible. The third type is Software as a Service, or SaaS. SaaS offers the consumer a finished product that is run and managed entirely by the service provider. No concern is necessary for how the service is managed or how the underlying infrastructure is run. The customer is only concerned with using the web browser of the application client. A common example of a SaaS application is web-based email. You can send and receive without having to manage other features or maintaining the servers and operating systems. Often, a SaaS provider is also using IaaS and PaaS themselves, and most often through Amazon Web Services. Examples of SaaS solutions would be CRM, Customer Relationship Management, Human Resources and Workplace Tools, Cloud Storage, Cloud Email and Collaboration, Digital Transformation and Automation, and Finance, Sales, and Marketing Services. Now that you've learned the 3 main service types, in the next lesson, let's look at the cloud computing deployment models. Let's look at the 3 main cloud deployment models that you need to know for the exam. Now, as you look at other types of initiatives like NIST or other certifications, they may list cloud deployment models like public and private and community, but for the exam, we need to be aware of the ones that AWS defines: cloud-based, hybrid, and on-premises. These are the 3 to know for the exam. A cloud-based deployment is fully deployed as a solution in the AWS cloud. Every component of the application operates in the AWS cloud infrastructure. Cloud-based applications have either been generated in the cloud, for example, using PaaS, or have been transferred from an existing enterprise. Cloud-based deployment models can be built on low-level virtualized infrastructure components. They can also leverage higher-level services that abstract from the management, architectural, and scaling needs of the core infrastructure. A hybrid cloud deployment is often the most popular. It's a method for connecting infrastructure and applications between AWS cloud-based resources and other resources that are not placed in the cloud. The most common type of hybrid deployment is between the provider's cloud and a standing on-premises enterprise. A hybrid cloud solution can be used to migrate, expand, or grow an organization's infrastructure into a cloud solution while linking internal systems to AWS cloud resources. It's often used by organizations to burst up to the cloud during peak demand times or special situations. A hybrid cloud may also be a disaster recovery plan or a temporary data migration for the purposes of analysis or to run machine learning algorithms and AI. Keep in mind for the exam that if your organization is completely on-premises, in other words, they have all of their applications and services and data on site at the headquarters, but you use something like Office 365 or Salesforce, a software as a service solution, that is not a hybrid cloud. In other words, just simply using SaaS doesn't make it hybrid. It has to be a combination of a cloud deployment and on-premises. An on-premises cloud deployment entails using virtualization and resource management tools on-site only, in your server farm, in your data center, in your network operations center. It's sometimes called a private cloud deployment, although resources can be hosted privately at Amazon Web Services. On-premises cloud deployments do not offer benefits of cloud computing, for example, the value proposition, but it's often needed for regulations and governance. The on-premises cloud deployment is very similar to a traditional IT infrastructure. The difference is that the entity is using hypervisors, application management, and other virtualization technologies to attempt to enhance resource utilization and lower costs. An example of a hybrid computing model is using the AWS Outpost service. This involves fully managed compute and storage hardware built with prototypical AWS design solutions. It extends the AWS services to a consumer's data center, co-location spaces, or on-premises facilities. You can emulate the AWS solution, or you can use VMware Cloud on AWS. Now, although this lesson is called an Introduction to Amazon Web Services, all of the previous lessons in this course have really been building an introduction, a foundation of AWS. But we're going to look at the four main services, the four core services of AWS, starting with the compute service. Then we have the networking and CDN or content delivery networking service, storage services, and database services. So, in a nutshell, our compute services involve server-based, for example, Linux and Windows builds, or serverless, functions in the cloud through AWS Lambda, or containers in the cloud through AWS Fargate. We also have networking using IaaS with our virtual private clouds, leveraging the AWS network infrastructure, but it also includes content delivery networking, getting that content close to your consumers at edge locations in metropolitan areas all throughout the world. Storage involves really two categories of storage: block storage on hard disk drives and solid-state drives, and object storage, for example, in AWS S3 service. And then database also has two categories: structured relational databases, like MySQL, and NoSQL or document-style databases, like DynamoDB. These are the four core services to know for the exam. Here we can see an example of the AWS global infrastructure. We've got a comparison here with Microsoft Azure. If you notice the little orange circles, those represent regions all over the world. Within those regions, you're going to have multiple availability zones. For example, the largest region, Northern Virginia, has 6 availability zones. In those availability zones, which are basically several miles apart on a metropolitan area network, you'll have one or more data centers. The data centers are nondescript locations where AWS houses all of their hardware, software, middleware, and employees running AWS. AWS has 24 launched global regions with 3 more coming. Each region has multiple availability zones. There's a total of 77 availability zones worldwide. And 245 countries and territories are serviced through the AWS global infrastructure. And there are 205 edge locations in metropolitan areas all across the world and 11 regional edge caches. That's for CDN, content delivery or content distribution networking. AWS is the industry leader. AWS is appraised as a leader in the 2020 Gartner Magic Quadrant for the 10th year in a row for cloud infrastructure and platform services. AWS offers 2 times more regions with multiple availability zones than the nearest competitor. In the next lesson, we'll explore setting up a free tier basic AWS account. All right, in this lesson, we're going to do a demonstration of creating your first 12 months of free tier access AWS account. Realize that you don't have to necessarily have an account to pass this exam. You are being certified as an AWS Cloud Practitioner, so that does assume that you're practicing at AWS. So it's not a prerequisite, but it doesn't hurt. And so we're going to go through the process here of opening up that first account for those of you who haven't done that yet. Now, if you've already opened up an account, you already have an account at AWS, then you can just skip this. But I'm going to give you some good suggestions that you might want to add to your knowledge base. So I went up and created an email address at Yahoo, kind of a dummy email address. I'll never use this again. And you're going to put in a password here. Now, this is for the root account. Okay, so you're creating a root account user. And this should really be a long, strong password. And we're going to talk more about this later. But you're probably rarely going to log back in as the root user. Only under certain circumstances should you do that. So this should be a really long and strong password, at least 8 characters. Okay, so I'm going to go ahead and do that. Next, you need to have an account name, and if you roll your mouse over the little I here, it'll say, choose a name for your account. You can change this name in your account settings after you sign up. And we'll click on Continue. It wants to know, is this a professional account type or a personal account type? Choose professional if you intend to use this AWS account within your company, educational institution, or organization. I'm going to choose personal, so I have no company name. We'll go back here. Notice professional would have company name and then basic other information, the AWS customer agreement, which you probably should open that up and take a look at that, right? When you sign up for things, look at the agreements. And this is not exam relevant, really, but it is something that you want to consider. So we're going to go back and we're going to do personal. They want my phone number and my address and my city and my state. I'm going to scroll down here, put in my postal code, and check the agreement. So we'll create our account and continue. Now, here's the deal. You have to have a credit card or a debit card. They have to verify your identity. And this is, an AWS free tier account. However, one thing about AWS you need to keep in mind, and they're different than Google Cloud Platform, and they're different than Microsoft Azure. They will start billing you immediately if you do things that are not within the actual free tier. So if you start incurring charges through other services that aren't free tier eligible, they'll start incurring fees immediately. And it tells you right here, we use your payment information to verify your identity and only for usage in excess of the AWS free tier limits. And we're going to talk about this later, but this is testable. So this information may be on the exam. For sure, these 3 elements, and we'll talk more about those later, but you'll always want to kind of make sure that you're aware of that. And so when you submit your payment information, they're going to charge $1 on the card to make sure it's valid, and it says it may show as pending on your statement for 3 to 5 days until they complete the verification process, and then they'll remove the charge, right? So I'm going to go ahead and go through that step. So they want to verify my identity. They can send me a text message to the cell phone number. Come down here and we'll do a security check, and then we'll send the SMS text message. My 4-digit code, that's not a secret, so we'll do verify code. And your identity has been verified successfully. Let's continue. So they're going to offer several plans. There is a basic plan, there is a developer plan, and there's a business plan available to the personal account. Now this is also testable. There's a fourth type of plan, which is the enterprise plan. Now I cover this in another training coming up, so we're just going to say we're doing the basic. So we're going to do new users getting started with AWS. You get 24/7 self-service access to resources for account and billing issues only, and you get access to the personal health dashboard and trusted advisor. So those are free. So we'll click on free. And here we are. Now they want you to personalize your experience. If you want to, tell them, what is my role? I'm interested in a certain area. Okay, so you can say, I'm into DevOps. I like IoT. I like gaming. I'm into storage, whatever. And then, of course, you may unsubscribe from receiving any AWS news and offers. So I'm going to go ahead and do that. And then you can go down and do some tutorials. Okay. Now, the next thing is going to be managing this root user account, which is going to involve some things in the IAM area, but we'll cover that in later AWS Cloud Practitioner training. But that's the process of setting up a free tier account in AWS, and I highly recommend that you do so. This will be the first of a series of short lessons that explore the AWS value propositions. The first of these being agility. We could also include in this flexibility. They're very similar in their design. With AWS as the producer and we as the consumer, we co-create value and deliver data, applications, services, and solutions to the world. And we do it in an agile and flexible way. This proposition also integrates with agile development, spiral development, and agile project management. Agility involves leveraging for rapid deployment, testing, experimentation, and innovation, overcoming geographical limitations, the ability to replicate and move data from one region to another, reducing time and cost for testing and experimentation, and getting content as close to the consumer as possible. The first AWS value proposition, agility. To learn about our next value proposition, elasticity, let's see what the folks at Netflix have to say. Elasticity of the cloud allows us to add thousands of virtual servers and petabytes of storage within minutes, making such an expansion possible. Leveraging multiple AWS cloud regions spread all over the world enables us to dynamically shift around and expand our global infrastructure capacity, creating a better and more enjoyable streaming experience for Netflix members wherever they are. That's from Yuri Izraelevsky, Vice President of Cloud and Platform Engineering at Netflix. Elasticity is the ability to almost instantly provision and deprovision resources. Elasticity leverages dynamic auto-scaling technologies as part of the solution. Circumstances can reveal how deprovisioning may be a more vital aspect of elasticity than provisioning. For example, the ability to deprovision your business running in the cloud during a global pandemic. Elasticity allows us to react to our demand almost instantaneously. Challenges with predicting demand often leads to higher costs. On the left-hand side, we see rigid on-premises resources, where our predicted demand does not meet our actual demand. The difference, of course, being waste, and the result being customer dissatisfaction, at the very least. On the right-hand side, with the elastic cloud-based resources, we can have our resources scaled to demand to meet the actual demand. In the following lesson, we'll look at the next value proposition, that being cost. We often think of cost as the most obvious and important value proposition, but for a lot of organizations, elasticity is the most important value proposition. For many organizations, using the cloud to reduce costs is the dominant factor in the value proposition. Enterprises can save on network infrastructure, devices, servers, racks, cabling, and more, not to mention moving to smaller facilities with a lower carbon footprint. The value proposition supports green initiatives and lower utility costs. Additional cost savings with AWS includes labor, training and certification costs, reduced maintenance and upgrades, smaller facilities, cost savings on disaster recovery sites, and lower cost of database and storage. By leveraging value-based pricing, we get more customers. We have more AWS usage, more access to their infrastructure, leveraging economies of scale of the cloud provider, thus lowering our infrastructure costs. AWS value proposition, security. AWS is responsible for the physical security of the facilities as well as the infrastructure that includes compute, database, storage, and networking resources. The customer is responsible for software, data, and access that sits on top of the infrastructure layer. In addition, their responsibility depends upon which type of service it is: infrastructure as a service, platform as a service, or software as a service. Security is a top priority of Amazon Web Services, and they are constantly offering new managed solutions to enhance privacy and security of all cloud resources. AWS has highly secure, nondescript data centers with stringent physical security and multi-factor authentication of their employees. AWS offers a privacy and security partnership through the shared responsibility model, sharing responsibility between themselves and their customers. The AWS security triad involves Identity and Access Management, IAM, Key Management Service, KMS, and Infrastructure Security. We'll learn about all three of these throughout this Cloud Practitioner training. Infrastructure security comes through various VPC design mechanisms, various firewalls, and a portfolio of managed services, such as AWS Shield, Guard Duty, and Inspector. In this first course, AWS Cloud and the Value Proposition, we covered the AWS Cloud Practitioner exam, cloud computing types and deployment models, setting up an AWS free tier account, an introduction to Amazon Web Services, and AWS Cloud Propositions. In the next course, we'll cover AWS Cloud Economics, AWS Pricing Models, and AWS Cost Calculators. Let's get an introduction into cloud economics at Amazon Web Services. AWS offers an enormous variety of services, products, and solutions that empower organizations to be successful and profitable in meaningful and measurable ways. Reports from various entities like Gartner and International Data Corporation IDC point out that AWS customers get important financial benefits that help increase growth, drive productiveness, and realize important long-term cost reductions. For example, AWS customers at the rate of 62% realize a more efficient IT infrastructure staff. 51% of those customers achieve lower 5-year cost of operations. 90% of the customers will be using less staff time to deploy new storage. 25% of AWS consumers attain more productive development teams, and on average, it only takes 6 months to pay back your outlays of costs for core services like networking, storage, databases, and compute. Gartner rates AWS as the best cloud provider. In the 2017 Magic Quadrant for Cloud Infrastructure as a Service worldwide, Gartner placed Amazon Web Services in the Leaders Quadrant and rated AWS as having both the furthest completeness of vision and the highest ability to. In this brief lesson, I want to compare AWS to other cloud providers. Global enterprises make larger annual financial commitments to Amazon Web Services. Organizations also deploy more mission-critical workloads on AWS. AWS has a broader range of customer profiles, ranging from startups and small and mid-sized businesses, SMBs, to large global enterprises. AWS is the most mature, enterprise-ready provider, with the strongest track record of customer success and the most youthful partner ecosystem. Here's the Magic Quadrant for Cloud Infrastructure as a Service worldwide. In the Leaders Quadrant, we have AWS, Microsoft, and Google. With AWS clearly the leader when we look at the vertical axis of ability to execute and the horizontal axis of completeness of vision. Also remember, the original Google search engine actually ran on an AWS service. Other cloud providers in the niche quadrant would be Alibaba Cloud, Oracle Cloud, and IBM Cloud. Bottom line, Amazon Web Services is clearly the leader, and you made a wise decision to get the AWS Cloud Practitioner certification. In the previous Course 1 in Lesson 7, I did a demonstration of creating your own free tier account at Amazon Web Services, and we noticed going through that process that we were reminded of the AWS free tier model. And there's 3 aspects to this model to be aware of on the exam. First, there are a wide variety of things that are 12 months free. For example, certain builds of Windows and Linux in the Elastic Cloud Compute Service, also a certain amount of S3 storage, DynamoDB tables, and others for 365 days from the day you create your account. And there's things that are always free. For example, your health dashboard, Trusted Advisor, and AWS Shield. And then there's free trials. In the AWS Marketplace, there are literally thousands of vendors and other SaaS providers that offer free trials for their platform as a service and software as a service solution. 30 days, 45 days, or 90 days, or even more. So remember, on the exam, those are the 3 elements of the free tier model. In the 12-month free tier option, customers are provided the ability to explore and try out AWS services free of charge up to specified limits for each service. Realize, of course, not all services are included. Services with a 12-month free tier allow customers to use the product for free up to itemized limits for 1 year from the date of the account creation. If your usage exceeds the free tier limits, you simply pay standard pay-as-you-go service rates. But realize, if you exceed free tier limits or you use other services that are not part of the free tier, AWS will start charging your card immediately. Some examples of 12-month free tier options: 750 hours per month of Linux T2 Micro or T3 Micro instances, dependent upon the region. 750 hours per month of Windows T2 Micro or T3 Micro instances, depending upon the region. 5 gigabytes of standard S3 storage. That's AWS's object or blob storage. 750 hours per month of relational database service, DB T2 Micro database usage. And 25 gigabytes of Amazon DynamoDB storage. AWS pricing models. AWS offers a pay-as-you-go approach to pricing for their large array of cloud products and cloud services. So you'll only pay for the specific services that you need and only for the time that you're utilizing them. You will only incur fees for the actual resources and services that your enterprise uses. With the pay-as-you-go model, you can easily adapt to your changing business needs. There's no more need to overcommit on budgets. You can improve your reaction and response time to changes and modifications, competitors, new technology. You can adapt your business to real needs and not forecasts. You can also reduce risks of overpositioning or missing capacity. The pay-as-you-go model aligns closely with the cost and elasticity value propositions. With pay-as-you-go pricing, organizations can stay agile and reactive to competition and innovation. Entities are always able to meet scaling demands within their budgets. Companies can better redirect focus on emerging technologies and modernization. Organizations can better reduce the difficulty and complexity of procurement, and businesses are empowered to be fully elastic and flexible. Another aspect of AWS pricing is save when you reserve. AWS offers a reserved instance option for certain services like Elastic Cloud Compute, EC2, and Relational Database Service, RDS. According to AWS, you could save up to 75% over similar demand by reserving capacity. If your enterprise pays a higher upfront fee, you'll enjoy a better discount. Let's say you're in the Elastic Cloud Compute or EC2 service, and you instantiate an M4 large virtual machine. You can reserve for 1 year with no upfront at 32% savings. You can reserve for 1 year with a partial upfront, giving you 42% savings, or 1 year all upfront with a 43% savings. The third aspect of AWS pricing is pay less when you use more. You can use managed services to help address your needs. You can get volume-based discounts. You can gain substantial savings as your usage increases. And you can take advantage of S3 object storage tier-based pricing. An example of pay less when you use more, you can get up to 50 terabytes of S3 storage for 0.023 cents per gigabyte per month, 51 to 100 terabytes of S3 storage for 0.022 cents per gigabyte per month, and 500 terabytes plus of storage for 0.021 cents per gigabyte per month. On the exam, it's important to remember these three aspects of AWS pricing: pay as you go, save when you reserve, and pay less when you use more. Now, before I jump into this demo, one thing to realize about the AWS Cloud Practitioner exam is that the first iteration of this exam was put out several years ago, and they haven't changed it. Okay, so it's still the same original number, original exam. So what that means is the names of things change. So to make sure that you understand possible changes that might be on the exam, the AWS pricing calculator is the new name for the total cost of ownership, or TCO calculator. So remember that for the exam. If you get a question on the TCO calculator, it's now called the AWS pricing calculator. And by the way, it tells you this is a tool to estimate the cost for your architecture solution. And by the way, if you want to come up here yourself, you can go and just say, click on what is the AWS pricing calculator. But here's how it works. You estimate the cost of AWS products and services, then you search and you add AWS services that you need. You enter the details of the usage to see what the service cost will be, and you can then see estimated costs based on service, the service group, and some other totals as well. And you can create an estimate without a commitment, and you can explore the services and pricing for your architectural needs. So when I come in here, I'm going to choose among 58 different AWS services, or I can come down and look at them in alphabetical order. Now, we haven't talked about a lot of these different services, and so we're not going to spend our time right now doing that. However, I have mentioned in the training so far, EC2, Amazon Elastic Compute Cloud. EC2 is a web service that provides secure, resizable compute capacity in the cloud. And so we're talking about Windows and Linux instances, and it's designed to make web-scale cloud computing easier for developers, right? And you can go to the product page, or you can click on Configure. And again, you're going to go through and kind of estimate what you're going to do. And then at the end, it'll give you a estimate or a total cost of ownership estimate. So again, remember on the exam, the AWS pricing calculator is the new name for the TCO, total cost of ownership calculator. I'm back up at AWS in the Billing Management Console. When the exam was originally put out, there was a tool called the AWS Monthly Cost Calendar. That tool is now called the Cost Explorer. So there's no monthly in the name, and it's now called the Cost Explorer, not the Cost Calendar. And by the way, on this exam, there is no configuration. So you won't have to actually walk through and use any of these tools. You just need to know how to describe them and define them. But just be aware that they still may call this the monthly cost calendar on the exam. But the Cost Explorer basically gives you some pre-configured views for common spending scenarios. And then you can obviously customize those for your situation. There's a monthly spend by service view, shows the monthly spend over the last 3 months grouped by AWS services. You can also see the monthly spend by linked account view, which shows the monthly spend over the last 3 months grouped by linked accounts. This is only available if you're using organizations, and we'll talk more about organizations later on in this training. But there's also a daily spend view, which shows the daily spend over the last 60 days. So you can just launch the Cost Explorer, or you can use one of these pre-configured views. For example, here's the monthly costs by service, okay? Now, also under cost management, if we go back over here, you can set up your budgets, you can set up your savings plans, and you can generate cost and usage reports as well. I'm going to go back over here to the pricing calculator. One thing I want to do is I want to recommend that you take a look at this site when you have a chance. It's aws.amazon.com/pricing. And this relates back to what we talked about in earlier lessons in this course. How do you pay for AWS? Remember, you need to know these three: pay as you go, save when you reserve, and pay less by using more. That'll be on your exam. Now, individual pricing of services will not be on this exam, so don't worry about that. But the free tier is also exam relevant as well, right? Always free, 12 months free, and free trials. And earlier in this course, I gave you some examples of these. For example, 750 hours of Amazon EC2, right? But there's some other things here. 750 hours of Amazon Relational Database Service. We'll learn more about that as well. There's also DynamoDB database. This is your document-style NoSQL database, 25 gigabytes of storage. Some machine learning through Amazon SageMaker, 250 hours. And if you want to do some compute without a server or of functions in the cloud, you get 1 million free Lambda requests per month as part of your free tier model. And there's others down here as well. And like I said, you can see on and on and on. There's quite a few services. And so this pricing page is a good one to come and take a look at as well. By the way, you won't have to memorize those kind of free tier amounts, right? But just be aware of the three main aspects of the free tier. In this course on AWS Cloud Economics, we learned about AWS Cloud Economics, comparing cloud service providers. We looked at the AWS free tier model, explored AWS services pricing, and the TCO and cost calculators. In the next course, we'll look at the shared responsibility model, Amazon machine images and virtual private clouds, and AWS networking. As we learned in previous courses, one of the main value propositions is cost of using Amazon Web Services. And one of the ways they do that is by using multi-tenancy on hypervisor technology. A hypervisor is the software that produces and manages a virtual infrastructure, allowing multiple operating systems to run and share resources on a single physical machine. Think of the hypervisor as a type of air traffic controller between the different operating systems and applications running on a single box or blade, managing the utilization and sharing of CPU processor cycles, RAM memory, and disk storage. The system running the hypervisor is called the host system, and the host should have a lot of computing power, memory, and storage for the virtual hard drives. The host system is commonly a rack-mounted server blade. However, it could be a laptop, or a workstation, or a personal computer. The virtual machines running on the hosts are called guests. Each virtual machine takes one set of physical hardware, which is CPU, RAM, disk drives, peripherals, and more. The multi-tenancy of guests usually involves operating systems like Windows and Linux, Mac OS, and others, as well as the applications running on those operating systems. There's two types of hypervisors. A Type 1 hypervisor is referred to as native or bare metal. Here, the underlying hardware, which could be a workstation tower or a server blade, actually accepts the installation directly of the hypervisor software. That's why it's called bare metal. The hypervisor is being installed into bare metal, not into another operating system. Then, in the hypervisor, you'll install multiple guest operating systems and, optionally, applications running within those guest operating systems. Not only does the hypervisor make sure that all of the guest operating systems and applications get the resources of hardware that they need, sometimes borrowing from one OS or another, but they'll also provide security to make sure that guest operating systems don't escape into the hypervisor or, if so configured, do not access other guest operating systems within the same hypervisor. Common Type 1 hypervisors are KVM, Xen from Citrix, Hyper-V, vSphere ESXi, and OVM. Amazon Web Services runs on Xen Type 1 hypervisors. The second type of hypervisor is the Type 2 hypervisor. For example, right now my hardware is a Dell Precision Tower 7810. I've installed on top of this Dell Tower a host operating system of Windows 10 Professional. Then, I've installed my hypervisor software inside of the host operating system. With Type 2, it's not bare metal. The hypervisor software is installed into another guest operating system. Common Type 2 hypervisors are Oracle VirtualBox, VMware Workstation, or VMware Player, or Fusion, Microsoft Virtual PC, and Red Hat Enterprise Virtualization. It's important to realize that before you take advantage of any type of service up at Amazon Web Services or move any data, let's say to block storage or object storage, that you understand the shared responsibility model. Securing your cloud resources is not the same as securing your on-site data center resources. When using a cloud provider like AWS, there is a sharing of operations and security responsibilities depending on the type and level of service. The model can assist in offloading the customer's operational load and overhead. Security compliance is also a shared concern between AWS and the customer. AWS functions, manages, and controls the mechanisms from the host operating system and virtualization layer that we saw in the previous lesson, down to the physical security of the data center facility. The consumer takes responsibility for managing the guest operating system, including updates and security patches, other related application software, along with the design of the virtual networks and logical firewall. The extent to which you use cloud resources will depend upon your risk treatment or risk handling. You may decide to reduce risk by using a more managed service. You may decide to accept risk by simply using the underlying infrastructure of Amazon Web Services and handling all of the rest yourself. For example, the operating systems, the applications and platforms and data. You may decide to avoid risk using a hybrid solution where you keep some of your services and data on premises or on site as opposed to deploying them in the cloud. And of course, transferring or sharing risk can involve using a cloud provider like Amazon Web Services. As mentioned, shared responsibility can be considered a form of risk transference or risk sharing. When you migrate resources to a cloud service provider, the service level agreement, or SLA, becomes a joint shared responsibility between the provider and the consumer. With infrastructure as a service and software as a service cloud models, this relationship has a more distinct demarcation point. With platform as a service, however, the lines are often less clear and depends on how managed the service is by the cloud service provider. In the previous lesson, we established the fact that the shared responsibility is a joint agreement between the consumer and the provider. In this lesson, we're going to look specifically at the responsibilities of Amazon Web Services as a provider. Security is a huge aspect of AWS's value proposition. AWS goes to boundless lengths to protect their global infrastructure. The investment they make would be difficult for most companies within their own data centers. AWS runs and manages all mechanisms from the host operating system and virtualization layer down to the physical security of the facility. The AWS global infrastructure is operated using security best practices and compliance standards over one of the most secure computing environments in the world. AWS offers many tools as well as data to support consumers in their efforts to get visibility and validation controls to effectively manage their environments. The AWS data center is a nondescript, undisclosed location with 24/7 security staffing. It uses multi-factor authentication for facility entry and entry into other areas with continuous monitoring, logging, and auditing. They use automated change and control processes. AWS uses Bastion services, for example, Systems Manager, Session Manager, to act as gateways for privileged access. And AWS deploys network boundary devices to monitor and audit access with intrusion detection and analysis. In an infrastructure as service, or IaaS model, the AWS provider responsibility lies in the gray area down below. They will protect their global infrastructure, which involves data centers and availability zones in regions all over the world. They also have secure edge locations in metropolitan areas all over the world. They provide their own identity access management, IAM, and secure endpoints to all their services within the AWS cloud, and protecting their compute, storage, database, and networking foundational services. An excellent resource to better understand the commitment that AWS makes to security is to check out their security blog and video article about their securing of their data centers. Let's do a web safari up to aws.amazon.com/blogs/security. In this lesson, let's talk about the AWS customer responsibility as it relates to the shared responsibility model. Customers have complete control over their content and are responsible for managing critical content security. They're in control of the content stored on AWS in block storage, object storage, and databases. They manage the AWS services used with the content. They decide the country where the content is stored. They determine the format and the structure, as well as the identity and access management access to that content. The customer responsibility depends on the type of service that's chosen. For example, a virtual private cloud with Elastic Compute Cloud EC2, relational database service, S3, Redshift, Lambda, and more. The particular service will actually determine the customer-side responsibilities. For example, with EC2 Windows instances, you would be responsible for managing all aspects of the guest operating system, including updates, upgrades, and security patching in an IaaS environment. Although compliance is a partnership and shared responsibility is a joint relationship, the customer is ultimately responsible for compliance, regulations, and adhering to attestation and auditing by third parties. In Course 1, we walked through the process of setting up an initial free tier account, and we talked briefly about that root account. However, there's some distinctives to understand about the root account for the AWS Cloud Practitioner exam. First, you should never programmatically access resources using the root account user. In other words, do not create an access key for the root account. If you must keep your access key, then rotate or change it regularly. To delete or rotate your AWS account access keys, go to the Security Credentials page in the AWS Management Console. Here, you can also set up multi-factor authentication MFA, which is also highly recommended for the root account. And never share your AWS root account password or access keys with anyone. Keep them well protected physical security standpoint. Remember, there are certain things that only the root account can do. For example, change the root account user details. For example, their password. Only the root account can change the support plan. For example, from business to enterprise, or the payment options, or change billing. For instance, from a credit card to direct billing. Only the root account can close an account, or sign up for GovCloud. Only this account can create an AWS-created X509v3 signing certificate, and only the root account user can transfer Route 53 domains to another. All right, in this lesson, we're going to learn more about virtual private clouds, or VPCs. But before we do, I want to start out here in the services area. And of course, you can search for a service by simply coming here and typing it in, and it'll take you to that service. So we're going to look at the VPC service here in a moment. However, I want you to know that we're going to focus in this exam, the Cloud Practitioner exam, on several of the areas of services. So compute services, and again, not everything under compute. So for example, you won't be tested on serverless application repository or AWS Outpost or Image Builder. But compute is the first area to be aware of. It's a core service. Then we have the core storage service, then the core database service, and then we'd have networking and content delivery. That's our fourth core service. We're going to look at some of the areas under security, identity, and compliance. That'll be on the exam. And then a couple of the other services under management and governance, okay? So we'll be learning about CloudWatch, CloudFormation, and CloudTrail. One of the things on this exam that you'll need to make sure that you can do is differentiate between these services that are very important that start with the word cloud. Now, they stopped doing that, fortunately, but as we get through this training, you'll need to be able to differentiate between CloudWatch, CloudFormation, and CloudTrail. If we go to the networking area, CloudFront. Okay, so there's these four different cloud services that start with the word cloud, and for the exam, you'll need to make sure you can tell the difference, and by the time we finish our training, you will be able to tell the difference, okay? So we want to do VPC. We can go down to the networking and content delivery area to get there, or often if you recently visit something, it'll show up over there on the menu. So we'll choose VPC from services. Now we're in the VPC area, the VPC dashboard. And if you notice down here, it tells you you're using the following resources, and these are the resources by region. So this virtual private cloud is deployed into a region, and this is in the US East or Ohio region, and it tells us that the service is operating normally. That's a good thing. Now, along with your VPCs are other types of network resources. You see all these down here. We're going to talk about these later on in this course when we get to networking. Okay, so I'm not going to cover all of these, but you'll need to be able to define what all of these elements are in the VPC. If I come over here to your VPCs, what I'm going to see is a default virtual private cloud. Hasn't even been named. I could name it if I want to, but I've got a virtual private cloud. Now this is the default VPC, and you have one per account. Now if I scroll down here, how do I know it's the default VPC? Well, it says right here, default VPC. So you have a default VPC, you have an owner the account owner, and then a unique identifier, okay? And it's available to me to use. Now, this is important. If you were to go create your own VPC, which you could by going up here and say create VPC, that is called a non-default VPC. So technically, there's only two virtual private clouds, a default VPC and a non-default VPC. And by the way, you could have hundreds, of VPCs in your account. Some customers of Amazon Web Services have over 1,000, approaching 2,000 VPCs in one account. Keep that in mind. Now, if you don't want to use the default VPC, because it has its own characteristics, so for example, all of the VPCs are going to be in a /16 CIDR or CEDAR range. So one thing we notice here is that AWS doesn't use subnet mask. So this is not going to be 255.255.0.0. It's /16, which basically means the first 16 bits, 172.31, is the network, and then all of the rest of the bits are for the subnets and the hosts in that network. And so, by the way, if we went to subnets, we would see that this virtual private cloud has 3 subnets. And these subnets, by the way, are going to be giving /20. So they give us these /20 subnets, and those are good because we have a lot of available IP addresses per subnet. So if you look at this /20 here, that's how many network bits there are. So if there's 32 bits in the IP address, 32 minus 20 is 12. And 2 to the 12th power is 4,096. Now, we don't get to have 4,096 available IPv4 addresses. We're going to lose 5. We can't use 172.31.0 because that is the network itself. The next available address, which would be the .1, that goes to the virtual router in this VPC, the one that this subnet's going to use. So the virtual router gets an IP address. The next address would go to a virtual DNS server that this VPC uses, and you're using that by default, even though you can turn that off and deploy your own DNS servers if you wanted to. And then the next address is going to be experimental, so that's going to be 4 of them right there. And then the highest bit, the highest address in this subnet is what we call the broadcast or the directed broadcast of this network. And AWS doesn't use that, so you can't use it as an address, but they don't use it either. So we lose 5 addresses here. Now, the reason why the default VPC gives you so many IP addresses is because, remember, we want to have enough addresses for all of our instances, our Windows and Linux instances, but also we may be doing that elasticity thing. We may be auto-scaling up those instances as needed, so we'll need IP addresses for those. And again, these are private IP addresses, right? These are from the RFC 1918 private address space. If you want a public address to go to the internet, we'll talk about that later. We also need addresses because if we want to get access to resources in the AWS cloud securely and bypassing the internet, we're going to use endpoints, either gateway endpoints or interface endpoints. And interface endpoints need IP addresses too. We'll talk about that later when we talk about networking. So notice, by the way, that we have by default 3 subnets in this VPC. Well, the VPC is in the Ohio region, and the Ohio region has 3 availability zones. So what they're doing is they're giving us, by default, 3 subnets. So if we want to put each one of these in a different availability zone to kind of get high availability of our resources, we can do that. That's subnets, and we'll kind of talk more about that in networking. Let's go back to the VPC dashboard. So we could create a new VPC by default, or we could launch the VPC wizard. So the VPC wizard is basically infrastructure as code. You could call this infrastructure as code light, because the full-blown way to do infrastructure as code is to use a service called AWS CloudFormation, which we'll learn about later. But notice we have 6 templates here, or 6 stacks that we can choose from. A VPC with a single public subnet, and we'll talk about what makes this subnet public in the networking lesson. A VPC with public and private subnets. So you have a public subnet with a NAT gateway, and we'll learn about that coming up, and a private subnet We also have a VPC with a public subnet and a private subnet, and the private subnet has a site-to-site VPN back to our corporate data center or some other site, and then a VPC with a private subnet only with a VPN back to the corporate data center. And so this is kind of a sandbox subnet. It's private. This would be called a private cloud. It's a private, isolated section of the AWS cloud. So we can cancel and exit. So we have our virtual private cloud, which is our own virtual network in the AWS infrastructure. It has a lot of network components that we're going to learn about coming up in this course. And by default, you have a default VPC in your account, and you can create your own non-default VPCs if you want to. And you can do it, one at a time by going to your VPCs and creating a VPC, or you can go back to the dashboard and use the Launch VPC wizard. Now notice next to this it says Launch EC2 instances. Well, we want to have something in our subnets, in our virtual private cloud, right? So we can launch instances here. We'll learn about that later. Or we can use the marketplace, or we can also use infrastructure as code to launch things into our subnets into our virtual private cloud. In the previous lesson, we learned about virtual private clouds, and we also talked about the fact that once you deploy that virtual private cloud, whether it's the default VPC that you're going to use, or you're going to generate a non-default VPC, something needs to be deployed into those subnetworks. And we talked about the fact that EC2, Elastic Cloud Compute Instances, is one of the most obvious things to deploy into those subnets. However, what exactly is an EC2 instance? Well, let's go to Services and go to the Compute area and click on EC2. AMI stands for Amazon Machine Image, and I've heard it referred to as an AMI or an AMI. I call it AMI because A for Amazon. If you go down here, you can see AMIs. Notice that it tells us about the AWS Marketplace, where you can find more than 500 AMIs of popular open source and commercial software, or you could build your own with the EC2 Image Builder. We're not going to do that. For the Cloud Practitioner exam, we need to be aware of how we define the AMI. If we go down here and launch an instance, the first step of this process is to choose an Amazon Machine Image, an AMI or an AMI. And it tells us right here what it is, and this is what you need to know for the exam. An AMI is a template that contains the software configuration, which includes the operating system and optionally application server and applications required to launch your instance. You can select an AMI provided by AWS, or we have community AMIs down here. You're going to kind of use these at your own risk, at your own discretion. And you can see we have a bunch of different Linux builds. There's the Amazon Linux build, which is their own version of Ubuntu, CentOS, Debian, Fedora, Gentoo, OpenSUSE, Red Hat, SUSE, Ubuntu. There's also Windows operating systems on different platforms. Now down here it says root device type. The AMI is going to include the root volume of that particular operating system. A little bit later on when we get to storage, we'll talk about the difference between EBS, Elastic Block Storage, and an instance store. You need to know that for the exam. Again, you can also have your own AMIs, and again, we saw the image builder for that. And then in the marketplace, all these different providers, and you can see under different categories, will provide AMIs for us, for infrastructure software, for DevOps, for business applications, for machine learning, for Internet of Things, IoT, and different industrial AMIs. Cancel and exit, launch instance again, get back to that page. So if we stay here on the choose an AMI, by the way, you can search for one right here and just type in whatever you want, Windows. But if you come down here, we'll see that Linux offers a couple of different categories of AMI. There's the Linux 1 and the Linux 2. This is a very popular build of Ubuntu that people use a lot. If it says free tier eligible, what that means is under their list of different options, they're going to have at least one that is free tier eligible. So this micro instance is eligible for free usage. And it says for the first 12 months following your sign-up date, you get up to 750 hours of this instance each month. when your free usage tier expires, or if your usage exceeds the free tier, then you'll pay standard pay-as-you-go service rates. Okay, remember, even though you've got a year of free tier access, you can use that up and start generating fees and charges immediately, right? So, use at your discretion. If we come down here, we'll see other Amazon-provided AMIs like Red Hat Enterprise Linux 8, SUSE Linux Enterprise Server Ubuntu. So if you deploy any of these, what you're really doing is you're participating in infrastructure as service. So you're responsible for, spinning up or launching, or what we would say instantiating an instance of this image for Windows Server 2019. And you're responsible for the licensing, for the configuration, for the updates, for the service packs, for the security fixes, all of those things. Remember, with IaaS, you're responsible for the operating system and anything that's installed on it. For example, like containers, or SQL Server 2017, for example, or SQL Server 2019. So this is all our deployment through EC2, Elastic Cloud Compute, of AMIs, or instances of Amazon machine images. And again, this is infrastructure as service, and that will affect your shared responsibility model. Now, if you don't want to deploy a underlying server and a database on top of it, if we scroll up here to finish up, if you want to use platform as a service, you can say, hey, let's go ahead and try the relational database service. So we'll talk more about this, but this is moving from IaaS to now platform as a service, where we're going to rely upon them to have the operating system and the platform of the database, for example, MariaDB, MySQL, Oracle, PostgreSQL, and SQL Server on the AWS infrastructure. So that would be a managed service, platform as a service offering we can take advantage of. A fully managed platform as a service for relational databases would be Aurora. And we'll learn more about the RDS in upcoming lessons in this training. Well, that's the AMI, the Amazon Machine Image. In this demonstration lesson, we're going to break down the network components of the virtual private cloud that you need to be aware of on the exam. Now, keep in mind, the Cloud Practitioner exam, despite the word practitioner, does not test you on the configuration of these elements. You need to be able to define what they are and what their usages are. So, for example, we already talked about the subnet, right? So we know that in this VPC, which is 8611E5ED, we have 3 subnets, and by default we have 3 subnets because the Ohio region up here has 3 availability zones. So they give us 3 subnets so we can deploy the same resources for high availability across 3 availability zones. Now, when we choose a subnet, which is basically just a logical VLAN or virtual LAN within the AWS Hypervisor infrastructure, we can see that it has an identifier. We see what VPC it's in. We see our available IP addresses. Again, so this is a /20. We'll talk about the network ACL later on. It's available. Here's the network identifier, 172.31.0.0/20, or the first available subnet in the 172.31/16 VPC network. Notice it has a route table. This logical route table, which is part of the AWS infrastructure, gets one of those IP addresses, and the route table is important. And let me tell you why. It is the route table and the entries in the route table that determine if this subnet is public or private or VPN, okay? So there's 3 types of subnets. There's a private subnet, there's a public subnet, and there is a VPN subnet. Now, how do we determine what type of subnet this network is? Let's go to route table right here. If we scroll down, we'll see that all traffic destined for the VPC address, that's all considered local traffic. Anything other than that, 0.0.0.0/0, that's the CIDR or CEDAR representation for any other network, is going to be sent to this IGW right here. So what is the IGW? Well, we're going to talk about that, but that's the Internet Gateway. So if the route table for a subnet has an entry for an internet gateway, it's a public subnet, right? So it has a gateway to get out to the public and to get back. So that is a public subnet. If I were to remove this entry, and I could by editing it, if I took this IGW out of here, it would be a private subnet. So with no way out of the VPC, it is a private subnet. The third type of subnet is a VPN subnet. So if I replaced this entry right here of this internet gateway, I replaced it with a VPN, virtual private gateway, or a VPG, I would add that VPG. So it would be VPG- something into this table. This would be a VPN subnet. So therefore, there's three types of subnets, and it depends on what's in the route table. And every subnet only has one route table. Now, can a subnet use a different route table or the same route table? Absolutely, they can use the same route table. But that's what a subnet is. And again, you can see we have one route table here. This route table is assigned to the VPC, and you can see that it has a local route, and then it has what we would call it kind of a default gateway to the internet gateway. And that's what we have next, internet gateways. An IGW, it's a horizontally scalable, routable gateway that does two things. One, it allows traffic in and out of the VPC, which we see here, but it also translates those private addresses, let's say 172.31.0. whatever, into public addresses. Well, let's talk about IP addresses next. When you go to bring up an instance, so let's go real quickly back to the EC2 area. When you spin up an instance, and I'm going to take you really quickly through that process to get you to that point, and we'll go to the configuration. When you launch an instance, it's going to ask you, do you want to auto-assign a public IP address to this instance? Okay, so we can say, yeah, let's enable that. If we do that, this instance will get a public IP address from the AWS pool, let's say 59.33.20.7. Now that auto-assigned public IP address from the AWS pool is assigned to this instance. So if you stop the instance or terminate the instance later on, that address goes back to the pool. So it kind of lives and dies with the instance. As long as the instance is running, it has the auto-assigned public IP address. If you stop or terminate it, you lose it. Now, what's the other type of IP address? Okay, so I could disable this auto-assignment and say, I want to go ahead and use a different type of IP address. And what would that be? Let's cancel out of here and go back to the VPC. The other kind of address is an elastic IP address. Okay, so the elastic IP address, basically, which you can go and you can see I have one here. The elastic IP address is also from the AWS pool. This one's 13.59.226.168. This is a publicly routable IP address. So I could go ahead and I could attach this to the instance. I can attach it, I can detach it. Now the beauty of the elastic IP address is if you stop or terminate the instance, you don't lose the IP address. It's yours. It's allocated to your account. So I can attach it to some other instance, Windows or Linux. Here's the deal though. If you allocate an IP address and you don't associate it with something, they're going to start charging you just a little bit. In other words, if you take one of their IP addresses from their pool and you make it your own and you don't use it, they're going to kind of ding you for it because, they like to have that address back into their pool. But those are the two types of public IP address, the auto-assigned AWS address or an elastic IP address, which is yours that you can attach and detach. Let's talk next about the NAT gateway, okay, the Network Address Translation Gateway. And the best way to do this is to go up to the VPC dashboard and go back to that wizard. Remember this option right here, the VPC with public and private subnets? In this option, they're going to give you what's called a NAT gateway. And they tell you right now they're going to charge you hourly for this NAT gateway. Here's what the NAT gateway is. These instances or these servers right here in the public subnet, they're going to go out to the internet and maybe other AWS services through the internet gateway, right? It's a public subnet, so we know we have an internet gateway. Now, what about these private servers? We have, let's say, database servers or middle tier servers or web servers or even directory controllers. What if these particular servers in the private subnet which don't have an internet gateway still need to get access to something on the internet, like Windows Update services. Or maybe they want to go over the internet to get to some S3 bucket, for example, which has a URL. Well, if these private servers want to do that, to go through the NAT gateway, right? So they're actually going to have an entry in their route table to the NAT gateway. That way, if they want something, they go through the NAT gateway, go up and get it in the internet or the AWS cloud, and they bring it back. Now, what happens with the NAT gateway is some user out here on the internet, they cannot create a session or start a connection through the NAT gateway to get access to these servers. So it's a secure way for a server in a private subnet to go out to the internet or maybe something as part of AWS's cloud and get access to it in a secure way. So that's the NAT gateway. By the way, the NAT gateway has to use an elastic IP address. So if I cancel and exit and I go to NAT gateway to create one, it's going to ask me, name it, choose what subnet it's going to be, and it has to be in a public subnet, and then assign an elastic IP address, which by the way, I have one, so I could allocate that one we saw earlier. That's the NAT gateway. Now remember, network address translation is only used by IP version 4. So the NAT gateway is for IPv4 traffic. What if you want to do the same type of thing for a server that's using IPv6? In that case, you use the egress-only internet gateway. So for the exam, remember, the egress-only internet gateway is kind of a translation gateway, but it's just for IP version 6. Now, Microsoft gave us DHCP, Dynamic Host Configuration Protocol. So for example, if you're not going to use the AWS assigned DNS server and you want to deploy your own DNS servers into a subnet, into your VPC, then you would go use the DHCP options. Managed prefix lists is not on the exam, so we're going to skip that. Let's talk about endpoints. An endpoint gives us the ability to go in and connect to services in the AWS cloud bypassing the internet, okay? And they're secure. So there's two different types of endpoints. We see type right here. What I want to find first is the gateway. All right, so we have gateway. The gateway endpoint is used to get access from an instance in your VPC or in a subnet to get access to two services in AWS. The DynamoDB, which is a NoSQL document style database. So you want to connect to a table in DynamoDB over the AWS cloud, not the internet. You'd use the gateway interface. And what that means is you're going to put an entry into the route table, just like you would in IGW, but an entry into the route table as a gateway to this DynamoDB service. That's the first use case. The next use case for using a gateway endpoint is the S3 service. So notice S3, which is their object storage, simple storage service, also uses a gateway. So if you want to connect over the AWS cloud, bypassing the internet to DynamoDB and DynamoDB tables, or S3 and S3 buckets, you use a gateway interface, which means you're going to put this right here in the route table, right? That subnet has a route table. You want to connect to S3, you'll put an entry in the route table. Now, the other types are called interface, and these don't involve an entry in the route table. If you choose an interface, so for example, let's say I want to do Elastic File System. Like here's Elastic File System. This is kind of cool because if I don't want to use a volume on my Linux server for files, I can just store them on the Elastic File System so I can shrink and grow. So if I want to do that, the Linux instance would connect to this Elastic File System and it would use an endpoint, but it would use an interface endpoint. So an interface endpoint basically is going to be a logical network interface. It's going to use up one of those IP addresses, one of those private IP addresses, and it's going to connect to the Elastic File System. And so there's a bunch of interface options. Basically all the other services that support endpoints other than S3 and DynamoDB. The interface endpoint will use a logical IP address from your pool, your private IP address pool, but the gateway endpoint does not. It's just an entry in the route table, okay? Let's go back. The final thing I want to talk about is the fact that if you have a VPC, you may want to connect it to another VPC and peer with that VPC. So you can send traffic from instances in one virtual private cloud to another virtual private cloud. So you would do that through peering connections. Now, here's the deal. You have to name this. And by the way, the configuration is not on the exam, but I want you to conceptualize this. Obviously, you're the requester, okay? So you choose your VPC. You're the requester. Now, if you want to connect to another VPC in your account, right? It's in your account. You have two VPCs, maybe a default VPC and a non-default VPC, right? Then you could connect those and you would be the one to request it and accept it. No problem. If it's another account, however, if you're the root user or the administrator of that other account, you can also be the acceptor. But if you're not the root user or the administrator of the other account, then whoever that person is, they will have to accept your peering connection, okay? Now, two other things. If you connect two VPCs together with a peering, the IP addresses cannot overlap, okay? So they need to be different IP address prefixes or ranges. That's one thing. The other thing is they're not transitive. They're non-transitive. So for example, if VPC1 trusts VPC2 and VPC3 trusts VPC2, that doesn't automatically create a peering connection through VPC1 and VPC3. Okay, they cannot transit VPC2, their common peer. You have to explicitly create a peering connection between VPC1 and VPC3. Okay, it's non-transitive. So remember, for the exam, you want to be aware in how you can define all of these elements over here on the left-hand side, except for the managed prefix lists and endpoint services. So that is our networking discussion for the AWS Cloud Practitioner exam. In this demo, I want to talk about secure connectivity options to your VPC. Now, in the previous lesson, we talked about VPC peering, and how you can connect those together. I want to talk now about virtual private networks, which is the primary secure way to connect to your VPC and the resources in that virtual private cloud. Now, obviously, we've learned about internet gateways, and that's how you access resources from the internet and vice versa. But let's look now at a virtual private gateway. The best way to approach this is to first create the customer gateway. So here's what the customer gateway is. Basically, you're just putting in the information about the device, either physical or virtual, at your headquarters, your main office, or some other branch office. So you put in some name and then determine how you're going to do routing. In other words, the devices or the hosts behind that device, they have to obviously know routes to resources in your VPC subnets. So will it be a static route, or are you going to use dynamic? If you use a dynamic routing protocol, your only option is to use Border Gateway Protocol, or BGP. In that case, you have to provide some autonomous system number. Now, if your organization doesn't have an ASN, then they're going to tell you here, well, that's okay. You can use one of AWS's private ASNs. 64,512 through 65,534. So you could put one of those in there. Then what they want to know is, what is the IP address of your gateway device, your edge router, or multi-layer switch, or firewall appliance, whatever it is, at the customer site. So you can put in the IP address, which would be a publicly routable IP address, or another option would be to have a certificate. So you could go to the certificate services of AWS, generate a certificate, an X509 v3 certificate for that particular device, and then you could just simply choose it here. So the good thing about the certificate is, if you need to change the IP address of that customer device, or if it's being dynamically assigned, you aren't authenticating that pure device with an address using a certificate. And so that's all you do. You just create the customer gateway. Then you'll create your virtual private gateway. And this is on the AWS side. So this would be something that you would use other than an internet gateway. Remember, this VPG that you're going to create, you would basically put this entry in the route table for that subnet so the traffic could go through the VPG gateway if it weren't local traffic. Here, you just name it and either choose the Amazon default autonomous system number or put in your own custom ASN if you have that, and you just create the gateway. And again, this gateway object will go in the route table for that VPN subnet. Let's cancel out of here. Once you create those two things, you could then go to site-to-site VPN connections and then just simply name it and then choose your virtual private gateway that you created, then choose your customer gateway that you created, give it an ID, and then you're up and running. Obviously, we're going to choose to do dynamic BGP. Notice it'll create two tunnels for us. So we have failover, right? So we have a tunnel 1 and a tunnel 2. As a matter of fact, we can even let AWS generate the inside IP version 4 addressing, which would be from the PIPA 169.254 range, and even a pre-shared key for us. So it's pretty awesome. And then, of course, if you need to, you can configure your IPsec IKE version 1 or IKE version 2 settings. These settings, by the way, and actually the configuration here is beyond the scope of the exam, but it's very easy to set up this site-to-site VPN connectivity. I'm going to go ahead and cancel out of here. Another option is a client VPN endpoint. This is what we would call a peer-to-site VPN. So to create the client VPN endpoint, you would name it and describe it, put in the client IP address, and basically what you're going to do is you're going to install OpenVPN, which is an open source VPN product on your endpoint, your mobile device, your laptop, your workstation, at your teleworker location, and then connect from this client VPN endpoint up to the AWS cloud. So that's another option you have for connectivity. I'm going to cancel out of here. So your secure connectivity is under the VPC area under Virtual Private Network, where you have your site-to-site VPN, which may be called Managed VPN. When the exam came out a few years ago, this used to be called a Managed VPN. So now it's called a site-to-site VPN. And then you also have the peer-to-site VPN, which is the client VPN endpoint. Those are the secure connectivity options you need to know for the exam. In this course, Cloud Architecture Design Principles, we covered the shared responsibility model. We understood the root account and its distinctiveness. We looked at AWS Virtual Private Clouds, or VPCs. We learned about AWS Amazon Machine Images, AMIs. And we learned networking essentials and AWS connectivity options. In the next course, we'll look at AWS Cloud Compliance and AWS Artifact. We'll learn about the CSA Consensus Assessment and the AWS Compliance Solutions Guide. I want to begin this course reminding ourselves of the benefits of cloud security and realizing that cloud security is organization-centric. It does depend upon the organization and the type of cloud implementation, IaaS, PaaS, and SaaS, or a combination thereof, or the cloud deployment model. Are they deploying entirely in the cloud, or is it a hybrid solution? Regardless of the type and the model, however, the customer or the consumer leverages the secure infrastructure and best practices of Amazon Web Services, the best in the world. We're inheriting all the best practices, policies, architecture, and operational processes used by AWS. It allows us to grow and innovate while preserving a compliant and secure environment. Again, some of the benefits of cloud security are the assurance that data is durable and safe and highly available, lowering our total cost of ownership while enhancing security, scaling rapidly and securely, and adhering to compliance mandates. It's this fourth point that we're going to focus on in this particular course. In the next few lessons, we'll cover all the compliance areas you need to be aware of for the AWS Cloud Practitioner exam. Let's look at the benefits of AWS compliance. Compliance services offered by Amazon Web Services allow us to realize the controls that they're offering. In other words, if you must be compliant to something like HIPAA or PCI DSS, you'll be introduced to a broader and wider set of security services than other ordinary customers. Compliance responsibilities are part of the shared responsibility model. However, it is still the ultimate responsibility of the customer or the consumer to maintain compliance to regulations, governance, and mandates. Compliance at AWS allows us to utilize governance-focused and audit-friendly services. Security, privacy, and governance enablers are constructed using traditional compliance programs. And as we'll see later on in this course, AWS offers an extensive array of control information, as well as compliance documentation. On the AWS Cloud Practitioner exam, you don't have to demonstrate knowledge of different compliance programs, regulations, or mandates. However, here's a partial list of some of the compliance solutions that AWS offers. SOC, System and Organization Controls, SOC 1 ASAE 3402, SOC 2, and SOC 3. These are comprehensive reporting frameworks put out by the American Institute of Certified Public Accountants, AICPA. For the U.S. government, there's FISMA, DIACAP, and FedRAMP. In the credit card industry, or bank cards, there's PCI DSS Level 1, and in healthcare and insurance, there's HIPAA. There's also compliance for ISO IEC 9001, 27001, 27017, and ISO 27018. Although you won't be tested on these specifically on the exam, as a homework assignment, it wouldn't hurt to go find some familiarity with these different compliance areas by doing a web safari. In this lesson, we're going to learn about AWS Artifact. Artifact is a console-based, on-demand, self-service auditing object retrieval service that offers quick and easy access to AWS compliance documentation and various agreements. Artifact is the complete resource repository with access to all AWS auditor-supplied reports, certifications, accreditations, and other third-party verifications. It's a one-stop source for reviewing, admitting, and handling agreements for all current and future accounts in an AWS organization. Artifact supports the action of due diligence by achieving continuous visibility into security and compliance through immediate access to various reports. In Lesson 6 of this course, we'll actually go up to AWS and take a look at Artifact. However, some of the documents you can download would be PCI DSS reports, Business Associate Addendums, BAAs, Compliance Status Tracking, AWS ISO certifications, System and Organization Control, SOC reports, and Review and Acceptance documentation. Remember this for the exam. In this brief lesson, we'll talk about the CSA Consensus Assessment Initiative Questionnaire. CSA is the Cloud Security Alliance. It's a not-for-profit enterprise with a mission to promote the use of best practices for providing security assurance within cloud computing and to provide education on all the uses of cloud computing to help secure all other forms of computing. The CSA offers the STAR, Security, Trust, Assurance, and Risk Compliance. First, there's CSA STAR Level 1. That's the CSA STAR Self-Assessment. CSA STAR Level 2 is the CSA STAR Attestation and Certification. CSA STAR Level 3 is Continuous Monitoring. In the next lesson, we'll take a look at CSA and these levels up at aws.amazon.com. This lesson will be a web safari, a demonstration of the AWS compliance area. Well, one of the first places you want to come to is aws.amazon.com/compliance. Here you can learn more. They give you some enablers of compliance. These are services we're going to learn about later on in this training. For example, Amazon Guard Duty and others. As we come down here, we can see the various compliance programs. Now, as I said, there's no reason to memorize all these different programs. However, realize that these programs can be global or they can be specific to certain geographic areas like the Americas, Asia Pacific, or Europe, Middle East, and Africa. So some of the global ones are the Cloud Security Alliance, which you've already mentioned, and we'll talk about more in a second. These are the ISO standards I mentioned. 9001, the Global Quality Standard, 27001, Security Management Controls, 27017, Cloud-Specific Controls, and 27018, Personal Data Protection. We've also got PCI DSS Level 1 for payment and bank cards. And then, of course, we've got SOC, as I mentioned, the System and Organization Controls. SOC 1 for Audit Controls Reporting, SOC 2 for Security, Availability, and Confidentiality. That also includes Processing Integrity, and SOC 3, the General Controls Report. Those are the global ones. Those are the ones that you should probably be more familiar with as you go forward with AWS certification. As we move down, however, we can see some that are specific to the Americas. For example, I mentioned FedRAMP, the Government Data Standards, FISMA, Federal Information Security Management, HIPAA, for Protected Health Information, and others. Earlier in this course, I also mentioned AWS Artifact. This is your no-cost, self-service portal for on-demand access to AWS compliance reports and for entering into online agreements. Now, not only do you enter into agreements, but you can use Artifact to terminate various agreements. Notice that AWS Artifact is free. Over here, you can browse different reports, and there's quite a few of them. Or we can go back and we can view various agreements. For example, the AWS Business Associate Addendum, BAA, and it shows you if it's active or inactive. I also mentioned the CSA. For the exam, remember, the Cloud Security Alliance is a not-for-profit organization with the mission to promote best practices for securing the cloud. Be aware of the CSA Consensus Assessments Initiative questionnaire. So, for example, here it is from February 2020. And basically, for the exam, let's just realize this abstract. The CSA Consensus Assessments Initiative questionnaire provides a set of questions the CSA anticipates that a cloud consumer and/or a cloud auditor would ask of a cloud provider, like Amazon Web Services. It provides a series of security, control, and process questions, which can then be used for a wide range of uses, including cloud provider selection and security evaluation. And it shows us that AWS has completed this questionnaire with its answers below. So just for example, you can see here's question ID number 1. Do you use industry standards such as OWASP Software Assurance Maturity Model for web services to build in security for your systems or software development lifecycle, SDLC? And the answer is yes, and here's the notes. So that's the CSA Consensus Assessments Initiative questionnaire. Just be able to define it based on this abstract. Then, as mentioned, there's 3 star level assessments. Level 1 is the self-assessment, and again, that involves using the CSA Consensus Assessments Initiative questionnaire, the CAIQ. There's star level 2, which is based on SOC 2, an attestation that AWS has been validated by a third-party auditor to confirm their control objectives are properly designed and are operating effectively. Star Level 2 certification is based on the previously mentioned ISO 27001. And then finally, Star Level 3 is continuous monitoring. There's no existing certification at this point in time. However, customers can use this AWS Security by Design program to offer control responsibility outlines, automate security baselines, configure security, and get auditing of controls of the AWS infrastructure, operating systems, services, and applications. So, Level 3 offers customers the tools they need to meet the requirements of continuous monitoring. They also mention an AWS Security by Design web page. However, on the exam, just be aware of these 3 different star levels for the Cloud Security Alliance. In this course on cloud security and compliance, we got a review of cloud security benefits, an overview of AWS compliance. We looked at AWS Artifact, the CSA Consensus Assessment Initiative Questionnaire, and the AWS Compliance Solutions Guide. In the next course, we'll explore Identity and Access Management, IAM, assessing AWS with the command line interface, and single sign-on and AWS Cognito. Let's begin this course by going up to the services area of Amazon Web Services and locating IAM, Identity and Access Management. It's going to be down here under the Security, Identity and Compliance area, and it's the first one on the list. It's IAM, or as I call it, IAM. We're now at the IAM dashboard, and the first thing we want to look at is going to be over here on the left-hand side under Account Settings. But let me just remind you while I'm here, a couple of security alerts that are popping up. First, it says this root user, okay, so I'm logged in as the root user of this account, has access keys enabled. We recommend you delete the access keys for this root user and instead use access keys attached to an IAM user to improve security. Of course, we're going to look at creating an IAM user here in this course. But to delete the access keys, you can follow this link right here. And you can see we've got an access key here, and we can go and just click on delete. If you want to create a new access key later on, we can also do that. So let me go ahead and delete that access key right now. Now let's go over to Account Settings, because under Account Settings, we have our password policy. So here's our definition. A password policy is a set of rules that define the type of password that an IAM user can set. Well, that tells us one thing. These password policies apply to the IAM user, not to the root account user. So I'm logged in as the root account user. Realize when I set this password policy, it is not going to affect the root user. However, it will affect any existing groups and users that I have. And I do have existing users. And right now, they are just basically subject to the default account settings. Now, if I go in here and I enforce, let's say, a larger length of characters, like 10 characters, the next time they log in, they will get a drop-down box, and it will tell them to recreate a new password that adheres to the new password policy. And so generally, we should have at least a 10-character password length. Typically, somewhere between 10 and 13 is a good best practice. You can require at least one uppercase letter, require at least one lowercase letter, require at least one number, and require at least one non-alphanumeric character, and they list the legal non-alphanumeric characters right here. So be careful. If you make the password policy too stringent, too difficult, they're going to write it down, or they're going to document it somehow, and it's going to be exposed most likely. So often what we can do is we can teach them to make really long passwords based on 3, 5, or 6 letter words separated by a dash or a dot. So for example, Tex-Mex -absurd -dolphin. That's a great 3 words I can remember separated by a dash or a dot. And by the way, that's a very strong password. We also have password expiration. So this is going to basically be how long is that password valid. So typically, we're going to have policies like 30 days, 45 days, 60 days, 90 days. We also have password expiration requires administrator reset, okay? So we can choose that option as well. We can allow users to change their own password. And we often do this with the new user, okay? So we'll see later on when we create a new user, we might want to give them the ability to change their own password to a new password. So we'll give them an initial password in their account, and then immediately they're going to change that to something that only they know. And then finally, prevent password reuse. This is what we call the password history, okay? So basically, how many unique passwords do I have to use before I can reuse a password? We often see this set at like 12. For example, let's say we do 12 passwords and then a password expiration of 30 days, right? So they have to change their password every 30 days, and then they have to have 12 unique passwords. So once the year rolls around, the following year, they can start reusing passwords they've used in the past. So that's often a common password policy. I'm going to cancel out of here, and that is the password policies, which is one of the first things you're going to do in the IAM. Before you even start creating groups and users, establish your password policy. And again, let me remind you, it's over here under Account Settings on the IAM menu. Okay, we're back in the IAM dashboard. And in this lesson, we're going to talk about groups and users. And this is kind of a crossroads because in your account, if you're not going to use single sign-on, for example, you're going to have users sign on to a directory service like Active Directory or Open LDAP or some other directory, then most likely you're going to create an access management initiative using groups and users. Remember, though, that you want to follow the best practice to grant least privilege access. Establishing a principle of least privilege ensures that identities are only permitted to perform the most minimal set of functions necessary to fulfill a specific task while balancing usability and efficiency. So, if users need elevated or escalated access, you would put them into a different group, or you could, on an ad hoc basis, elevate their privileges. So what you're probably going to do is create a group of users, and this group, for example, we've got admins, we've got auditors, we've got developers, will be based on a wide variety of factors or variables. So it could be based on departments. It could be based on, if you have an organization with organizational units and lots of accounts, these could be based on a project or a program or a 6-week agile development lifecycle. So a wide variety of factors of why you would group up the users. We'll go ahead and create a new group here. We'll call it the testers group and go to the next step. And what you're going to do is you're going to apply a policy, a managed policy to that group. Now, we're going to talk more about these managed policies in the next lesson, okay? So I'm just going to go ahead and grab one real quickly just to go through the process to get to the next step. I've applied a policy, which is a set of permissions, to this group. And then what we're going to do is we're going to add our users to those groups, because whenever we add a user to the group, that user will inherit the permissions that we assigned to the group. I could approach this a couple of ways. I could go to the testers group and then add a user, or I could add a user right now. Let's say Sam S. And notice, of course, this user can have programmatic access and or management console access. Now, if we give them programmatic access, they're going to get an access key ID and a secret access key. The access key ID is a pseudo-random name for the access key. I only want to give Sam S programmatic access if they're going to access AWS resources using the API, the command line interface, the software development kit, or other development tools. Notice in the previous lesson, we deleted the secret access key for the root account user, and you definitely want to do that. So if you're going to do that, delete the secret access key for the root access user, most likely you will be creating another group of users that will be having programmatic access. Now you can also give Sam S console access. So not only will Sam S have a set of key IDs and an access key, But SAMS could also log in with an email address and a password. I can auto-generate that password for SAM, or I can give SAM a custom password. And then I can also say, look, users must create a new password at next sign-in. And that's typically a good thing to do. Whatever auto-generated password I give them, they're just going to create a new one, and it'll be based on that password policy that we saw in the previous lesson. Whatever our password policy is, SAM will have to create a password that is based on that password policy. Notice when I check off this box that this user will automatically get the IAM user change password policy. And so the next thing I can do is I can assign permissions to this user. Now, typically what we do is we add the user to a group. That's the most scalable, centralized way to do it. So I would add SAMS to my new testers group. Now, could I copy the permissions from some existing user and apply them to SAMS? I could. I can also directly attach policies to the user. Typically, we don't do that when we're using groups. Is there an exception? If you create a single user that has the highest level privileges called administrator access, often we'll have a user that is kind of a fallback user with kind of godlike privileges. We may assign that user the policies directly, and it would be administrator access. So often we don't put that user in a group at all. In this case, we do have a group called admins, and so those users would be put into that group to get this high-level policy. So that is our options. I'm going to cancel out of here. So for the most part, our approach is to create groups for whatever reason based on our account, and then we place users in those groups, and they inherit the policies, the managed policies that are assigned to the groups. Admins here, or auditors, or developers, or testers. In the next lesson, we will talk more about these AWS managed policies and exactly what they are. Okay, we're back at the IAM dashboard, and now let's move over here and go to the policies area, where we're going to see a listing of managed policies. And they're going to be in alphabetical order for a wide variety of different services. As a matter of fact, there's 729 managed policies. Now, what exactly is a managed policy? Well, let's look at the highest level managed policy, administrator access. When we click on that, we can view it in a couple of different ways. We can look at it under the policy summary kind of graphical representation, where we're going to see all the different services in alphabetical order. The access level is full access to all the resources, and there's no conditions. If we look at the JSON, which, by the way, if you're going to be working in the cloud, specifically AWS, then JSON's going to be in your future. If we look at the JSON for this managed policy that provides full access to AWS services and resources, we'll see in the JSON that basically in the statement, the effect is to allow all actions on all resources. And that's true. However, there are still some things that this administrator access policy cannot do, and that is a list of activities that only the root account user can do. For example, closing out an account or changing your billing plan, like adding a new credit card or going to direct billing, changing your support plan from, let's say, basic to developer or business or enterprise. But this is the highest level permission. If we were to go back to policies, we can also type in here administrator, and we'll see there's a database administrator, there's a network administrator, there's a system administrator. So if you don't want to use that full-blown admin access, you could go give somebody database administrator, and you can see here in the JSON, you're going to have, more limited access. And if that's still like a foreign language, click on Policy Summary. Now, these are policies that can be applied to a group. They can be applied to a user. In the next lesson, we'll talk about roles, okay? So policies can be applied to roles as well. And realize, typically, we're applying policies to groups. For example, the developers group has this one policy. Now remember, for the exam, you can apply up to 10 managed policies to an entity, whether it be a group or a user or a role. You can have up to 10 policies, so basically 10 stacks of JSON documents. If there is any type of deny rule in any of those, it will supersede any permission in any of the managed policies. So deny takes precedence and will counteract any type of permission. So be very careful with your deny rules. If we go back to the dashboard, you do have some resources that are not testable on the exam, but you can go in a real-world scenario and look at the policy simulator, which allows you kind of beforehand to go look at a particular group, for example, let's say like developers, and you can see they have the DynamoDB read-only. And so DynamoDB is the underlying database of S3 and Glacier. So if we said, let's go take a service like, I don't know, let's look at Glacier. So we'll scroll down here, find the G's, and there's Glacier, and say, here's actions, and these are all of the API calls or API requests that could be made in Amazon Glacier. So let's select all of them, and then let's run a simulation of what some group or user with this managed policy can do in Amazon Glacier. Run the simulation, and you can see, well, even though DynamoDB kind of is underneath Glacier blob storage, everything is going to be denied, okay? So you can use the policy simulator to kind of, get an evaluation of the ultimate effect of your managed policy. That's a tool that you might want to use in the real world as well. Then another tool that's relatively new is the Access Analyzer. So this is a tool after you've deployed your IAM implementation. This is a tool that uses machine learning algorithms to go through, and once you create your analyzer, review your findings and take action. So it can find privilege creep. It can do a gap analysis, and you can find areas that you need to kind of fix in your policy to fill in those holes, those access holes, and the privilege creep that can happen after time. So that is our managed policy, and it's highly recommended that you use the managed policies, even though you could go and copy one of these and modify it, rename it. You could even create your own policy from scratch, okay? And you can do it through the visual editor, where you choose your service, actions, resources, and possible conditions, or you can write it in JSON. On this exam, the Cloud Practitioner, by no means are you expected to be able to create a policy or actually even know any JSON. Just realize that the managed policies are created by AWS. They're highly recommended, and you can apply up to 10 policies to a group, user, or role. And we'll talk about roles coming up in the next lesson. In this lesson, we're going to follow up on something we saw earlier in the IAM area, and that is roles. We know that we can apply a managed permission to a group, we can apply it to a user, but we can also apply a managed permission to a role. A role is an identity that has a permission assigned to it. A role is intended to be assumed by a user or an application, like EC2, or a service, like a Lambda function. It can be a third-party service that's part of a federation, or it could be a user in a different account. A role does not have long-term credentials, like passwords or keys. AWS actually offers temporary credentials for the lifetime of a session. It does it through the Secure Token Service, STS. And a role is often used to give access to identities outside of AWS. In this diagram, let's assume we want to give access to some groups or users in a development account over on the right-hand side. Instead of recreating those groups and users over in the production account, we can simply assign a role to those users in the development account. That's the trusted account. So, in the trusting account, where the resources are, for example, an S3 bucket called My App, we'll go into that account and we'll go to IAM roles, and will assign a role to a user in a different account. That way, the user has temporary credentials so they can access resources in the S3 bucket for a limited amount of time. Something else we can do is actually assign a role to a third party. Here's an example of Google Cloud Platform's stack driver, which is now called Operations. Once you're in Google Cloud Platform Operations, you can create a workspace. Notice when we create that workspace, the first question they ask us is, do you want to monitor AWS accounts within this Google Cloud Platform workspace? In a moment, we'll go up to AWS and look at these steps of logging into IAM and clicking on roles and creating a new role. What we're doing here is we're choosing another AWS account and saying we're requiring an external ID. Then we put in the information from Google Cloud Platform. We're assigning the read-only access managed policy permission and creating the role. Let's go up to the IAM console and take a look at configuring roles. I'm in the IAM dashboard. Over here on the left-hand side of the menu, we'll click on Roles. Notice it tells us here what roles are. A secure way to grant permissions to entities that you trust. So, I'm in the trusting account, and I can grant permissions to an IAM user in another account. I can apply it to application code running on an EC2 instance, an AWS service that needs to act on resources in my account, or users from a corporate directory who use Identity Federation with SAML 2.0. Let's click on Create Role, and notice the trusted entity could be an AWS service, for example, EC2 or Lambda. Those are very common use cases. In fact, if I go down and click on EC2, I'll actually have several use cases. Assigning a role for AWS Systems Manager, for example. I can also trust another AWS account or a web identity. We can use Cognito or any OpenID provider, or a corporate directory like your own Open LDAP directory. If I choose another AWS account, I can come down and put the account ID, and then if I want to, for example, in the previous operations or stack driver use case, I could require an external ID and put the information from Google Cloud Platform. Another example is assigning a role to an EC2 instance. For example, if I look at my roles, if I scroll down, I can see I have several roles. Some of these were made for me. Some of these I made myself. For example, Bastion Host. If I look at Bastion Host, I can see that this particular role has the Amazon EC2 full access managed policy. I can assign up to 10 policies to a role. So for example, I might want to bring up a Bastion host or a jump host in a public subnet and assign this role to it, so this defines the only API calls it can make based on the IAM policy. How would I do that? Let's go to Services, go to EC2, and we'll just bring up a instance. We'll launch an instance of Ubuntu, Amazon Linux 2. We'll select that. We'll just stick with the T2 micro free tier eligible, and then click on Configure Instance Details. Notice as we scroll down, we can assign an IAM role. So we can say, I want to assign the Bastion host role to this EC2 instance, or if it were several instances, or into an auto-scaling group, all those instances would have the Bastion host role and the associated managed permissions that are assigned to that role. In the previous lesson, we learned how to assign a role to an EC2 instance that is serving as a Bastion or a jump host. Let's talk more about the concept of a Bastion host or Bastion services. A Bastion host is a system whose goal is to offer secure access to a private network from an external network, like the Internet. The Bastion must be hardened to reduce the chances of exploit and penetration. Notice this diagram. We have manually launched instances in public subnet 1 and public subnet 2 across 2 availability zones for high availability. Teleworkers or administrators at the headquarters or branch offices can use Secure Shell 2 on port 22 to connect to these Linux instances and then jump, for management purposes, to other instances in the public subnet or to workloads, for example, databases, in the private subnets. The use of Bastion or jump hosts is a traditional solution to provide a secure management session to instances in public and private subnets. However, Amazon Web Services is going to recommend using managed services. For example, AppStream 2.0 is a dynamic Bastion service from Amazon Web Services. It'll spin up fresh instances each time a user requests access. AppStream will then automatically terminate the instance once the management session is complete. To use AppStream 2.0, you must have single sign-on in place, for example, using AWS SSO. And you must use an HTML5 desktop browser. Another option besides AppStream 2.0 is to use AWS Systems Manager and use the Session Manager service. Simply install an agent on your EC2 instance, use Session Manager to initiate a Secure Shell 2 session, and then from that point on, you don't have to reestablish the Secure Shell session to get secure management access. As we saw earlier in IAM, we can actually create a user with programmatic access. If that's the case, most likely they'll be using the command line interface, either for Windows, Linux, or Mac OS. For example, when we create this user called administrator and we give them programmatic access, they're going to get an access key ID and a secret access key. The access key ID is actually kind of a pseudo-random username for the secret access key. The secret access key, or a key generated from that key, will be used to digitally sign the API calls made as a programmatic user. This user will get an email with the access key ID and access key included. That user, administrator, can go up to aws.amazon.com/CLI and download the 64 or 32-bit Windows installer, or if it's Mac and Linux, they'll use Python 2.6.5 or higher, and they'll install using the pip command. Pip install AWS CLI. Remember that command for the exam. The Windows user will install through the AWS Command Line Interface Setup program. Let's say our administrator is using a Windows 10 professional machine. They can right-click on command.exe, run as administrator, and then, in the console, issue the command AWS configure, as seen here in the screenshot. Then, they can copy and paste their access key ID and their secret access key into the graphical interface. Then, they'll choose a default region name, for example, North Virginia, and a default output format. If they select Enter or None, the default will be JSON. The other two options are text and table. Table is recommended for new users who don't know how to write JSON. Let's talk more about access keys. Applications running outside of AWS will need access keys. For example, the Software Development Kit or the AWS CLI. AWS SDKs will have digital signatures performed automatically. Digital signing protects the message integrity by preventing tampering. Any signed request must reach Amazon Web Services within 15 minutes of the timestamp, or it will be denied. And the signing protocol version 4 also offers forward secrecy. In other words, the actual access key is not used for the digital signing, but rather a key derived from that key. Now, in your account or accounts in your organization, you may decide to use the IAM groups and users, but you may also determine that the best solution is single sign-on. If you have many IAM accounts and many users, you might want to consider SAML 2.0 federation to enable single sign-on. In other words, you have your own identity provider, such as Active Directory, eDirectory, or OpenLDAP, or some other directory service that supports SAML 2.0. Now, traditionally, you would go through the workshop, Choose Your Own SAML Adventure, a self-directed journey to AWS Federation Mastery at Amazon Web Services to create single sign-on access to AWS account resources like S3, DynamoDB, Elastic MapReduce, and possibly other SaaS solutions like Workday or Salesforce or Office 365. With AWS single sign-on, for example, with an organization that uses Active Directory, you can replicate an instance of Active Directory up in the AWS cloud. Then, as the user comes in and signs on to their workstation or laptop, they have a portal which gives them access to the AWS organization, different accounts, and different organizational units. They can also access custom SAML 2.0 applications and software as a service solutions through Office 365, Dropbox, and Workday with their single sign-on credential. And hopefully, that user is combining other factors like two-factor authentication with a smart card, an authentication token, or a biometric. For AWS customers who develop apps, for example, on the iPhone and the Android, they can provide single sign-on using the AWS Cognito service. Amazon Cognito provides user pools and identity pools. A user pool is a custom directory that provides sign-up and sign-in options for your app users. For example, when you register an app or web application, you have the option to fill out your own profile. That'll populate the user pool in AWS Cognito. User pools let you quickly, easily, and securely augment sign-up and sign-in features to mobile and web apps. For example, you can use a Lambda function to force them to use two-factor authentication through Google Authenticator, or a 6-digit code in an SMS text or email. Cognito is a fully managed service that scales to support hundreds of millions of users. With identity pools, you can offer a wide variety of authentication providers. Your users can authenticate using a wide variety of public providers like Amazon, Apple ID, Facebook, Google, Twitter, and other OpenID and SAML solutions. Keep in mind, changing the application ID that your identity pool is linked to will prevent existing users from authenticating using Amazon Cognito. In this course on AWS Access Management, we covered IAM password policies and managed policies, IAM groups, users, and roles, AWS Bastion services, command line interface access, and AWS single sign-on, and Amazon Cognito. In the next course, we'll look at AWS firewall solutions, distributed denial of service protection services, DDoS, guard duty and key management services, KMS. Let's begin this course looking at the first type of firewall, which is a network ACL. And the network ACL or NACL is actually a defense in-depth mechanism that's not being used by default. So let me show you what I mean. Here, we're in the default VPC. We know that because as we scroll down here in the VPC dashboard, we can see that this is the default VPC. And it tells us here that our main network ACL or NACL is ACL and then this number. Now, to go look at this ACL, we can come down here on the left-hand side and go to where it says security, and then we'll see network ACLs, and we'll click on that. So here's my network ACL that we just saw, and it's associated with 3 subnets, and that's by default because I'm in the Ohio region, and the Ohio region has 6 availability zones, so they give me 3 subnets by default. What the network ACL is, it is a stateless or a static packet filtering firewall that applies to all traffic inbound to a subnet, in this example 3 subnets, and all traffic outbound from the subnets. So we have inbound rules and outbound rules. And this network ACL will apply to all of the instances, everything in that subnet. And when I say it's stateless or static, what that means is the NACL will actually evaluate each individual packet or datagram one at a time, coming into the subnet and going out of the subnet. It's agnostic to any type of TCP connection or UDP flow, or the fact that it's a response to an ICMP message. It just looks at each packet one at a time, makes a decision, and then goes on to the next packet. So if we come down here and look at the inbound rules going to these subnets, rule number 100 basically says we're going to allow all traffic from all protocols on all port ranges from any source. So that's kind of the default behavior. It's not actually going to deny anything. Now, we have this little asterisk here. This is what we call an implied or an implicit deny all. Let's go to inbound rules. Typically, we edit and we start allowing, with number 100, traffic that we're going to have coming into our subnet. So, for example, I can scroll down here and say, I want to allow individuals to manage these Linux machines, for example. So I'll allow secure shell traffic, protocol port number 6, on port range, and this is basically saying from any source, but when you pop over, you might want to be a little bit more specific about who can manage the machines in this subnet. And they tell you, for example, if it's a host at your main office or a branch office, just put in 203.0.113.5/32. And again, we're going to then allow the traffic. And you just keep adding your rules. Now, when you add the rules, you want to skip by 5 or 10 so that later on you can insert rules if you need to, not have to renumber everything. Also realize that an ACL is going to process starting with the lowest number and then go to the next number. And as soon as it finds a match, it looks at the packet, it evaluates the headers, and as soon as it finds a match, it will take that allow or deny action. And then no rule after that, for example, 110, 115, none of those rules will be evaluated. So often what we do with the NACL is we put in these allow rules to kind of whitelist our traffic, and then let the implicit deny all or deny any deal with the rest of the traffic. And that's the network ACL. Again, it is stateless. It's a static packet filtering firewall. Whatever you allow inbound, you have to also allow outbound. And it applies to everything in the subnet, and you can configure allow rules or deny rules. In the next lesson, we'll look at our second type of firewall, and that is security groups. All right, we're back up into the VPC Management Console, looking at our second type of firewall, the security group. And like the network ACL, the security group basically operates at layer 3 and layer 4 of the OSI or TCP/IP model. In other words, IP addresses and TCP and UDP ports. A security group, however, is quite different than the NACL. For one, the security group is going to be associated with an instance, with its interface, specifically the logical elastic network interface of the instance. So whereas the NACL applies to all of the instances in a subnet, the security group applies to all traffic inbound and outbound from a specific instance. Now, in the previous lesson, we learned that we have a default network ACL. Well, we also have a default security group. When we go into the security groups area here on the left-hand side on the menu, we can see security group ending with AFB is the default security group. And it has inbound rules and it has outbound rules. However, the rules of the security group are not numbered. It basically just has a set of whitelisting rules for you to allow traffic to the instance and from the instance. Also remember that a security group does not have a deny rule. And you can see the inbound rule by default basically says we're going to allow all traffic into this instance if it's another instance using the default security group. In other words, no traffic will be allowed to this instance by default, for example, from the internet. Outbound, however, by default, we're going to allow all traffic on all protocols, on all port ranges, to any destination. The security group is a stateful packet filtering firewall. What that means is if an instance generates, let's say, a TCP handshake out to a web server through an internet gateway, we can see that the outbound rule will allow that, but it's also going to be monitored or tracked, so the traffic will be allowed back in. You don't have to whitelist it with an inbound rule. That's what a stateful firewall does. It tracks the TCP connection or UDP flow and automatically allows the traffic back into the instance if it was generated from the instance. Now, it's also subject to inspection as well. So, for example, later on in this course, we'll talk about AWS Shield. There will be some defense from common denial of service and DDoS attacks. Also remember that if you have rules in your network ACL that applies to the subnet that this instance is in, that NACL can block the traffic in or out. So whatever rules you whitelist in the security group, they need to be consistent with any ACLs or rules in the access control list. Now, you don't have to use the default security group. You can create your own security group. And notice when you do that, you're going to name it, you're going to describe it, and it's going to be assigned to a particular VPC. Now, it has no inbound rules, but you can see you can go and you can just simply add rules. So, for example, like on the NACL, we can add secure shell. We can say from any, or we can put in a particular IP address or other site or block, and then we can describe it. Now, notice in the security group, there are no numbered rules. So we would just keep adding our rules in here. Say, for example, we want to add HTTP, and the security group will evaluate all the rules. It will only allow what you put in the security group. So basically, it evaluates all of the entries and then makes a decision. If it doesn't match one of these whitelisting rules, it will deny it. And again, you have inbound rules and you have outbound rules. Let's go take a look at how we would apply a security group to an instance. I'm going to cancel out of here. I'm going to go back to the VPC dashboard where I can launch an EC2 instance. I'll just choose the free tier eligible Linux 2, T2 Micro, next configure instance details. Stick with the default storage. Don't add any tags. And notice it says next, configure the security group. So again, the security group is assigned to the instance. In this case, a Linux instance. Now, I can select an existing security group, which would be the default security group, right? We saw that. And you can see that, it gives us kind of our rules right here. But if I didn't want to do that, I could create my own security group, and I could add my rules right here. Or if I'd created my own custom security group in the security group area, when I chose select an existing, it would show up there. Now, a question that often comes up is, can I apply 2 security groups to an instance? And you can. It's going to combine all of the whitelisting entries and allow those things, but it's not recommended. And then finally, there's a warning down here that rules with a source of 0.0.0.0/0 or any allow all IP addresses to access your instance. We recommend setting security group rules to allow from known IP addresses only. And so I can configure and apply the security group when I'm going through and spinning up an EC2 instance. So remember, the security group is a stateful packet filtering firewall that's applied to the instance. It has no deny rules. It's a whitelisting firewall, and you have an inbound rule and an outbound rule, and you have a default security group that you can apply, or you can create your own security groups. In this lesson, we're going to move up to layer 7 of the OSI model and look at what we call a deep packet inspector, or advanced visibility and control mechanism at AWS known as the Web Application Firewall, or the WAF. Some vendors refer to this as a Layer 5.7 firewall because it operates on the application layer of the TCP/IP model. In other words, simply permitting and denying HTTP traffic is not enough. We're going to look deeper, over 8,000K, into the packet or datagram to examine the HTTP request headers and response headers. The AWS WAF lets you control and monitor the HTTP and HTTPS requests forwarded to Amazon CloudFront, which is AWS's content delivery or content distribution network, Application Elastic Load Balancers, ELB, or the API Gateway. Remember, the WAF can run on the application Elastic Load Balancer, not the network Elastic Load Balancer. You can deploy the WAF in a permissive manner. In other words, you're going to allow all of the HTTP requests made through the WAF except for the ones that you designate for blocking. Or you can deploy the WAF as a restrictive firewall, where you block all the requests made through the WAF except for the ones that you designate to allow. For example, you're going to block all HTTP methods except for the GET method and the HEAD method. Or you can deploy the WAF as a counting firewall, where you count the requests that match the properties that you specify as a preliminary mode, for example, to monitor the effect of your firewall, or you can use it to set limits for HTTP requests. With AWS WAF, you can go beyond the metadata in the Layer 3 and Layer 4 headers. You can actually match on the country of request origin. If it's permissive, you can allow all countries except for a few countries. If it's restrictive, you can block all countries except for a few countries. You can match on the originating IP version 4 and IP version 6 addresses. It can either be an entire prefix or individual addresses. The WAF can look for values in the HTTP request headers. For example, you can permit or deny certain HTTP clients, or only allow certain types of content. You can match on the lengths of URIs, HTTP arguments, fields, and field counts. This is a common countermeasure against buffer overflow attacks. The WAF can match on literal string patterns or regular expression string patterns like cmd.exe, an attacker trying to run a console session against a front-end web server. The WAF can examine looking for the presence of SQL injection code, for example, running various SQL commands to modify, delete, or get data from a back-end SQL database. It can look for the presence of cross-site scripting XSS code, specifically Type 1 and Type 2. And it can look for the presence of cross-site request forgery XSRF code. Denial of service attacks are very common threats against cloud resources. These can come in the form of flooding attacks using TCP and UDP, amplification and reflection attacks. ICMP can be exploited to overwhelm services at Amazon Web Services. AWS Shield provides denial of service and distributed denial of service protection at no extra cost. When you have an account at AWS, the resources in your VPCs automatically get the benefit of AWS Shield Standard, basic protection against common DOS floods and exploits. You can also get additional protection from known distributed denial of service attacks and botnets. Most common DDoS attacks actually come from botnet servers. And AWS Shield can be combined with network access control lists, security groups, and web application firewalls for layered or defense in depth. AWS also offers expanded DDoS attack protection for a price, and that's through AWS Shield Advanced. At the time of this recording, Shield Advanced costs $3,000 a month. Shield Advanced is for elastic load balancers, CloudFront distributions, and Route 53 hosted zones, as well as protection for resources in your virtual private cloud subnets. It offers access to the DDoS response team, DRT, 24 hours a day, 7 days a week. To use AWS Shield Advanced, you must have a business support plan or an enterprise support plan. Those are the only two plans that support 24/7 AWS team response. AWS Shield Advanced gives you access to advanced real-time metrics and deep visibility reporting for denial of service and distributed denial of service and botnet attacks. In this lesson, we're going to talk about the fully managed vulnerability assessment tool at Amazon Web Services. Amazon Inspector is an automated security assessment service that enhances security and compliance of applications running on the AWS cloud. Inspector automatically evaluates applications for vulnerabilities and nonconformity with established best practices. AWS discourages their customers from running their own assessment tools. Amazon Inspector can produce a detailed list of security findings on behalf of the customer. Inspector can produce the results and make them available through the console or an API. And the Inspector managed service includes a knowledge base of hundreds of rules. And finally, Inspector can generate a wide variety of meaningful reports. The next security solution I want to talk about is Amazon AWS GuardDuty. GuardDuty is a fully managed threat detection service. And when I say fully managed, that's exactly what it is. You basically just turn it on. There's no user-side configuration, so to speak. You enable it, and AWS and its consortium of partners, like Fortinet, Rapid7, CrowdStrike, and others, will deliver real-time threat detection and management. GuardDuty will look for attacks, anomalies, and unauthorized actions. It's going to do this using proprietary machine learning and artificial intelligence, along with its partners. These attacks and anomalies are based on well-defined findings categories, such as brute force attacks, turning off CloudTrail, deleting logs, indicators of cryptojacking, and other malware. Once you enable GuardDuty, it will start monitoring your flow logs, CloudTrail API trails, S3 data events, and DNS log activities. GuardDuty is a regional service with prices based on the quantity of events and log volumes. And it's highly recommended for all medium and large-size organizations, especially those with business and enterprise support plans running operational loads and mission-critical services in the AWS cloud. I want to pop back up to aws.amazon.com to talk about this next security service, which again is under Security, Identity, and Compliance, and it's called the AWS Key Management Service, KMS. And basically it's telling us right here what we can do is easily create keys and control encryption across AWS and beyond. As we scroll down, it kind of tells us how it works. And basically what's happening under the hood is that we're using hardware security modules. So KMS runs on hardware security modules. Those can also be abstracted for customers into what's called Cloud HSM. And so basically KMS lets us use those HSMs to centrally manage and securely store our keys. We can generate keys, we can import them from our own infrastructure. Our keys never leave the KMS infrastructure, and we're always in control of those. In addition, all requests to use these keys will be logged in AWS CloudTrail, so we can track who used it, how and when the key was used. So, the main benefits, they're fully managed, centralized key management, integrated with almost all AWS services and applications. You have built-in auditing. It's very secure. It's FIPS 140-2 compliant, and they're extremely reliable. KMS uses highly durable storage and a resilient architecture. to make sure our keys are always available and they're never lost. And again, you can see some related tools and services. I mentioned Cloud HSM. Now, if I go over here to the left-hand side, I may have some AWS managed keys, and I think I have a couple of them. Okay, I've got an AWS managed key for S3, and I've got an AWS managed key for Lightsail, but I can also generate my own customer managed keys. So if I say I want to create a key, it's going to ask me what type of key do I want to create. Now, a symmetric key, basically where the same key is used to both encrypt and decrypt, we're going to use that for encrypting data at rest. So, for example, in elastic block storage, for example, or S3, I can use those keys. Or I can do asymmetric key pairs. If I choose this option, it's going to ask me, are you going to create a key pair for public key encryption, where the public key encrypts and the private key decrypts, or are you going to use the asymmetric key pair for digitally signing? For example, digitally signing an API call. So I'll just say symmetric keys. And I'm going to go ahead and click on Next. The alias, I'll call this test key. I could put tagging on there, but I'll click on Next. And then, of course, it's going to say, choose the IAM users and roles who could administer this key through the KMS API. Now, I'm logged on as the root user in this account, so I'll for sure be able to do that, but I think I'll go ahead and add administrator here because they have the highest privilege level IAM managed policy. I'm also going to allow key administrators to delete this key if they want to. I'm also going to say who can use this in cryptographic operations. Administrator, and I could also add another AWS account, which I'm not going to do. And then, of course, here's our JSON policy for that key. So now I have a key. I've got an alias, which I just kind of, threw a bunch of characters out there. Here's the key ID, and this is basically a pseudo-random username for this key. And it says the specifications are symmetric default. This is basically a AES 256-bit key. I'm going to exit out of here and go take a look at a couple of ways I could apply this key. If I go to Services and go to S3, I go to a bucket and go to Properties. For default encryption, I can click on Edit, enable it, and say, you know what, I want to use AWS Key Management Service, and I can choose from one of my master keys, and there it is. So I can use the master key I just created, or I can create a key here dynamically if I want to do that. And so now everything in this S3 bucket, all the objects, will be encrypted and managed through KMS with this master key. If I cancel out of there, I could also go back to Services and go to the EC2. And if I scroll down in EC2, I can see I've got elastic block store volumes. I could create a volume and say, you know what, we'll just stick with general purpose solid state drive, 100 gig, and then encrypt this volume, and then choose a master key. And there's the key I just created. So again, we can encrypt object storage at rest in S3, and here I'm encrypting block storage at rest in an elastic block store. And of course, you can see right down here, learn more about KMS keys. Feel free to do that on your own time. This is all you really need to know for the exam when it comes to the key management service. In this course on security support resources, we got a survey of AWS VPC firewalls, specifically network ACLs and security groups. We learned about Web Application Firewalls, WAF. We explored AWS Shield, Standard, and Advanced. Learned about AWS Inspector and AWS Guard Duty. And then finally, got a demonstration of the Key Management Service, KMS. In the next course, we'll look at EC2 Linux and Windows instances. We'll explore auto-scaling and elastic load balancing. And we'll also explore several other core AWS services.